Hello everyone. Today we are going to discuss about a topic number systems, which is one of the topic in the course called Fundamentals of Digital Electronics. So myself, Dr. Harikrishna, Associate Professor in the Department of ECE. So let us move on to the topic, today's topic, number systems. Okay, so number systems, if you see what are the contents which we are going to discuss in the presentation, we will be discussing about the counting in decimal and number binary number system, and what is the place value in case of any number system, and how to convert a binary number to decimal, and also how to convert a decimal number to binary, and other number system like octal number system and hexadecimal number system. So these are the contents which we are going to discuss now. So moving on to the first one, that is nothing but counting in decimal and binary. So here, if you take what is the first of all a number system, it is nothing but a code using symbols. Okay, a code using symbols is said to be a number system. Okay, then coming to decimal number system. So decimal number system, as we are all well aware of, it is the number system used by us frequently and most familiar number systems for us. So this particular number system is having 10 symbols. So those 10 symbols are nothing but 0 to 9. Okay, so that means the base of the decimal number system is said to be 10. Whereas when it comes to the binary number system, it uses two symbols. So those two symbols are maybe 1 or 1 and 0. Sometimes we call them as a true and false, up and down. Okay, like that different notations can be used or different symbols can be used. Overall, it is said to have base 2 system where there will be only two symbols in binary number system. And coming to the place value of any number system in general, or is specifically here, let us see one example. So place value means nothing but for any number system, the position of every symbol will have certain place value. So in this example, if you see, this is related to binary number system. So the least significant bit in the binary number system is having a position 1, next one having position 2, next one having position 4, next one 8, if you go on like that, 16, 32, 64, like that. So now as an example, I consider a binary number called 0110. So the least significant bit position is 0, whereas out of these given 4 bits, most significant bit is having 0. So the overall, the given binary number system is 0110. So the positional value or place value, if you consider in 8th position, we have binary number 0. So the result will be 8 into 0, whereas plus overall value if you want to find. In 4th position, we have a number 1 whose positional value will be 4. That means 4 into 1. And in 2th position, we have 1. That means 2 into 1. And lastly, in 1st position, we have binary value 0, whose value is 0 into 1. So overall, the binary number 0110 is equal to decimal value 6, because it is nothing but 0 into 8 plus 1 into 4 plus 1 into 2 plus 0 into 1. So overall we will get a decimal value of 6 when we consider the positional or place value of the given binary number 0110. So coming to the next point, now let us see here, there is a binary number given and we want to find out what is its decimal equivalent. So here the decimal equivalent, if we want to find out, again it is same as a previous example where we can say that, so here 1000111, it is the given binary number, and the positional or place value of each binary number, if you see, MSB is having a place value of 32. Next 64, 16, 8, 4, 2, 1. Wherever there are zeros in corresponding to those place values, so 0 into that place value. So here if you consider the given number corresponding to 32, there is a binary value 1, so its value will be 32 into 1, plus corresponding to place value of 2, we have 1, so 2 into 1, plus least significant bit 1, whose position place value is also 1, so 1 into 1. Overall, the result or decimal equivalent of the given binary number 1000111 is 32 plus 0 plus 0 plus 0 plus 2 plus 1, which is 35. So this is how for any given number we need to convert to decimal, means we need to write its positional value or place value, multiply with 1 or 0 depending on the given binary value, and sum of all these products will give you the final decimal value. Now other way, that means how to convert decimal number to binary. Here it is simple process which involves dividing with the 2. So here our destination number system is here of base 2. The given number system is of base 10. So simply we divide the given decimal number with the help of destination base, which is nothing but 2. So here decimal number 11 is given. So first when we will divide 11 with 2, we'll get a quotient to 5 and a remainder 1. Then next, the whatever the quotient obtained in the first division, you take it as a number and divide it with 2. Okay, when 5 is divided with 2, we will get a quotient 2 and a remainder 1. Next 2 again divide with 2, you will get a quotient 1 and a remainder 0. Last, that 1 again if you divide with 2, you will get a quotient 0, remainder 1. Now overall, what is the equivalent of the binary equivalent of the given decimal number 11 means, so from the last remainder to first remainder, so 1011 is a equivalent of decimal number 11 in binary. So this is how we need to convert given decimal number to binary number. So the simple process is, you take the decimal number, you go on dividing with 2, because our target number system here is binary and its base is 2. Simply divide the given number with the base of the target number system. So that is how we can get the equivalent of binary given decimal number system. Coming to another number system. So in number system, mostly we use decimal, octal, binary and hexadecimal. These are the 4 commonly used number systems. Okay, so already we have seen how, of course, decimal number system is very familiar to us, whereas binary number system is used by computers. So other than these two, we have 2 more number systems called octal number system and hexadecimal number system. So as we have seen already, any number system with the base n will have n different symbols. So octal number system is going to have base 8. So it will use 8 different symbols. Like decimal number system base 10, we have 10 different symbols 0 to 9. Whereas the binary number system is having base 2 and it has symbols, 2 symbols 0 and 1. Coming to the octal number system, it has base 8 and it uses 8 symbols. Those 8 symbols are nothing but 0 to 7, total 8. Now, because here if you observe this table, the first column is our familiar number system decimal and its equivalent to binary. Okay, and the last one is octal number system. So one decimal equivalent of 1 in octal also 1 only, 6 equivalent in octal also 6, 7 equivalent in octal also 7 only, But when it comes to 8, decimal 8, decimal 8 is not going to present in octal number system. 0 to 7 only. 8 symbols will be present in octal number system, 0 to 7. So what comes after 7 means last digit or last symbol of the octal number system is 7. Next comes 1 0. So that's why decimal equivalent of 8 is represented as 10 in octal, and whose binary equivalent is, so here 10, they should be treated as two different symbols, 1 as a symbol, 0 as a second symbol. So the binary equivalent of 1 is 0001, whereas binary equivalent of 0 is 000. In the same way, when it comes to 9, decimal 9 is not going to present in octal, okay, because maximum symbols are 0 to 7 only. So here 9 means nothing but 11 in octal. Again 11 in binary will be 001 001. This is how we need to represent the symbols in binary which belongs to octal. So octal number system is having base 8 and it uses 8 symbols 0 to 7. After 7 it will be 10, again 11, 12, 13, 14, 15, 16, 17. After that 20 again. So any symbol which is a part of octal number system should be represented with the symbols 0 to 7 only. So that's why after 7 we won't get, if it is a decimal we will get 8, but in hexadecimal that 8 is represented as a 10. So this is how the number system, octal number system, and its 8 symbols will be represented. Now coming to the another number system which is frequently used one is a hexadecimal number system. So the hexadecimal number system, here the base is 16. So that means there will be 16 different symbols. So those 16 different symbols are 0 to 9, total 10 digits, and after 9 A to F alphabets, okay, 0 to 9, 10 numbers, then A to F alphabets. That's why since if you observe binary, decimal and octal, there are only numbers. So binary having 0 and 1, octal having 0 to 7, whereas the decimal number system having 0 to 9 symbols. Whereas hexadecimal number system totally there are 16 symbols. So 16 symbols we can't represent with the help of numbers only. That's why we take the help of alphabets as well. So 0 to 9 total 10 symbols and A to F another 6 symbols. So since it is a combination of alphabets as well as numbers, this particular number system is also called as a alphanumeric code. Okay, so total 16 will be there. And again coming to the what is the equivalent of some decimal number system in hexadecimal as well as binary, straight binary. Here it is called straight binary. So 1 same as hexadecimal or binary, 1 only, and decimal 9 also hexadecimal it will have decimal 9, whereas 10 hexadecimal 10 there is no place for 10 in hexadecimal, but generally in decimal 10 comes after 9. So whereas in hexadecimal that 10 is represented with the help of alphabet A, okay, and its binary equivalent is 1010. And coming to the 15, decimal 15 in straight binary we represent with the help of 4 ones, whereas in hexadecimal also decimal 15 equivalent is nothing but F, which is the last symbol in hexadecimal number system. And when it comes to decimal 16 again 16, decimal 16 not present in hexadecimal. Why? Because 0 to 9 alpha numbers and A to F alphabets. Overall there are 16 symbols starting from 0 to F. That means F equivalent is 15, then what is the equivalent of the number that comes after 15? That means F. In hexadecimal number system, the equivalent of F is nothing but 4 ones, and whereas 16, decimal 16 comes after this F. So in the previous example in octal number system, what we have seen is highest symbol is 7. The one that comes after 7 is treated as a 10. In the same way, in hexadecimal, highest number or symbol is F, or in decimal it is 15, and whatever comes after that is nothing but represented as 10. So 10 is hexadecimal 10 is equal to decimal 16, and in binary it is represented with 1 followed by 4 zeros. So this is how, that means 0 to 9 numbers, and alphabet A represents decimal 10, alphabet B represents decimal 11, alphabet C represents decimal 12, alphabet D represents decimal 13, E represents 14, and F represents decimal 15, and whichever comes after 15, that means by adding 1 to F we'll get a 10. Okay, so this is about hexadecimal number system. Now let us see the conversion, hexadecimal and binary conversion. So how to convert hexadecimal number to binary, and how to convert binary number to hexadecimal. So here example, if you take hexadecimal number is B3. B is nothing but B comes after A in hexadecimal number system. That means B is equivalent to decimal 11. And 3, of course 3 is the same in decimal or hexadecimal. So the binary equivalent, because here if you see in binary number system equivalent, we are using 4 bits. Why? Because highest number present in the, or symbol present in the hexadecimal number system is F. So the representation of highest symbol F requires 4 bits. So that's why in any hexadecimal number system representation, for every symbol or digit we use 4 bits for its representation. So that's why B, which is equivalent to 11, is represented as 1011. Again 3, even though it doesn't require 4 bits to represent, because every hexadecimal number system we are using 4 bits to represent, so 0011 we are using to represent. So this is how we can convert any hexadecimal number to binary. And the reverse process, coming to the binary to hexadecimal conversion. So when some binary number is given, what is the equivalent hexadecimal? So once, if we have practice, directly we can say, for example, here binary number 1101 and 1010 is given. So directly if we can find out what is the equivalent, that is well and good. Otherwise, better option is, when you are not familiar, first convert this binary to decimal and write its hexadecimal equivalent. That is one of the easy way in the beginning. So 1101 is binary number and its equivalent decimal is 13. Okay, so the 13 equivalent, decimal 13 equivalent in hexadecimal is D. Similarly, 1010 decimal equivalent is 10. The decimal equivalent of 10 in hexadecimal is A. So this is how we can convert a binary number to hexadecimal. So binary number should be in the form of 4 bits. Even if the given number is not having 4 bits, you can append zeros and convert it to hexadecimal. Coming to hexadecimal to decimal conversion, because why we use a hexadecimal to decimal conversion is, most of the time our familiar number system is decimal number system. So always it is easy to convert some number system to decimal, and from that decimal to another number system conversion, this will be very easy. So that's why here hexadecimal number is given. So if we want to find out its decimal equivalent, so here we use the concept of place value, which we discussed already. So the given hexadecimal number is 2BD. So D is having in the least significant position and 2 is present in the most significant position. So the place value of each symbol we need to assign, because the given number is hexadecimal. So the hexadecimal place values are, so here the least significant symbol D will have 1 position, place value 1. The next one B will have position place value 16, and the next one will have 2, which will be having place value 16 square, that means 256. So the place value of 2 is 256, place value of B is 16, and place value of D is 1. So now, because we are interested in decimal value, so the digit or symbol multiplied with its position or place value. Okay, so the most significant digit is 252, 2 multiplied with its place value. So 2 into 256, 512, plus the next one B, which is equal to 11 in decimal, and its place value 16. So 16 into 11, 176, plus the last one D, which is nothing but decimal 13, and its place value is 1. So 1 into 13. So overall, the decimal equivalent of the given hexadecimal number 2BD is 512 plus 176 plus 13, which is equal to 701. So this is how we need to convert given hexadecimal number to decimal number system. So for the given hexadecimal number system, first to write their place values. Each symbol write the place value and multiply with its position. That means 2 into 256, 11 into, which is equal to B, into 16, and D into 1, where D value is 13. So this is how we can convert any hexadecimal number to decimal number system. And then, so this is about briefly about a number system, which is a part of the fundamentals of digital electronics, the first topic and simplest topic called number system. So here what we discussed is what is a number system. So simply nothing but a number system is nothing but it uses symbols. Okay, how many symbols means that depends on its base, number system base. So here we discussed about 4 number system: binary, octal, decimal, and hexadecimal. Binary number system is having base 2, so 2 symbols 0 and 1. Octal number system has base 8, so 8 symbols 0 to 7. Decimal number system is having base 10, so symbols 0 to 9. Whereas coming to hexadecimal number system, it has 16 base and 16 symbols are 0 to 9 numbers and A to F alphabets, total 16. And how to convert binary to decimal and decimal to binary, and binary to octal, octal to binary, and hexadecimal to binary, hexadecimal to decimal, decimal to hexadecimal. So the conversion also we have seen. So this is simply about the number system and the conversion between various number system. So thank you very much for your patient listening. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.